So we were discussing about thermochemistry in our previous enrichment classes, but since we are already into electrochemistry chapter, so we have solved some of the problems regarding thermochemistry. So here is the time to get into electrochemistry in enrichment class as well. As the regular classes, we are already aware of these rules and regulations and the concepts, what to do, what not to do. So here also, let us start solving few problems. Initially, since it is the first enrichment class regarding electrochemistry, our preliminary target will be to solve simple problems, comparatively easier problems. So the first question goes like this: aluminium oxide may be electrolyzed. Aluminium oxide may be electrolyzed at 1000 degrees Celsius to furnish aluminium metal. Given is atomic mass of aluminium is 27U. We know what is U. And to prepare, cathode reaction is also given. Cathode reaction is given as Al3 plus 3 electron, giving rise to aluminium. So the question is to prepare 5.12 kg of aluminium metal by this method, how much electricity will be required? How much electricity will be required? Now, in order to solve this, first importance has to be given to the cathode reaction, because that is the main reaction based on which the reaction takes place, or based on which the calculation takes place. So here we can see Al3 plus 3 electron giving rise to aluminium. So straight away we can see to deposit 1 mole of aluminium, we need 3 into 96,500 coulomb. And 1 mole of aluminium is nothing but 27U. So straight away we can write that 3 into 90, or rather just the opposite way, we can write to deposit 27 gram of aluminium, we need 3 into 96,500 coulomb. To deposit 1 gram of aluminium, we need 3 into 96,500 divided by 27 coulomb. And in order to get 5.12 kg, that is 5.12 into 10 to the power 3 gram of aluminium, we need 3 into 96,500 divided by 27 into 5.12 into 10 to the power 3 gram. So this is the scenario. So it is 5.12 into 10 to the power 3 into 3 into 96,500. So this, whatever will be the answer of this much, will be our desired answer. So you should calculate. I'm just writing the answer straight away because I am having the answer. The main thing is to understand this much. This answer is just the outcome of that concept only. Just I'm writing it, you calculate it by yourself. The answer as per the book is 5.49 into 10 to the power 7. 5.49 into 10 to the power 7 coulomb. Anyway, simple problem. I hope all of you have understood. Let us proceed for the next one. Now, if we proceed for the next problem, the question is like this. X gram of silver is plated out on a tray by electrolysis of a solution containing electrolysis of a solution containing silver in +1 oxidation state for a period of 8 hours at a current of 8.46 ampere. Question is, what is the area of the tray? Question is, what is the area of the tray if the what is the area of the tray if the thickness of the silver plating, if the thickness of silver plating is 0.00254 centimeter. Now, let us solve it out. First of all, you read it once again. What is the question and what is the requirement in order to have the answer? First thing first, silver is on a +1 state. So it should be silver plus accepting electron giving rise to silver. Now, in order to calculate Q is equal to I into T, we have to understand that it is, how much it is? 8.46 ampere into 8 hours, that is 8 into 60 into 60 That should be the total amount. So we are keeping it as it is. This is the Q, this much of coulomb. We can say in this particular case that since it is one electron transfer, and for silver we know it is 107.8 gram, from 1 mole we are getting this, so we can say 1 into 96,500 coulomb will give this. So straight away we can write 96,500 coulomb will give you this much gram of silver. 1 coulomb will give you 107.8 into 96,500 coulomb. We have to see by passing this much amount of electricity how much silver we can deposit. So what we can do is, for 1 coulomb it should be, sorry, it will just be divided by 96,500 coulomb, and by 8.46 into 8 into 60 into 60, we will get 107.8 into 8.46 into 8 into 60 into 60 divided by 96,500 coulomb. Now this is the total amount of silver that will be deposited. It is pre-calculated. I am getting it as 272.18 gram. So this is actually mass of silver deposited. I hope you have got my point. But if you re-observe the question is what is the area of the tray if the thickness is this much? So we need to understand the total volume. Suppose this is the tray, okay? Suppose this is the tray. So there will be some kind of thickness. Suppose this is the area of the tray. Suppose this is how the tray looks like, and the black part, this is the coating. What does it mean? This simply means that this part is the coated area. That means this thickness, and then this is the area, this region. So total volume is nothing but area into thickness, right? I hope you have understood the thing that I am trying to say. So question is, the thickness of plating is given. What is the area? What is the area? To get that, I am erasing this part. I am erasing this part once again. And we find the answer as this. Area is given. We know that density is equal to mass by volume, and total volume we need to get. So volume should be mass by density. In the question, actually, one more data is given that I have not written earlier. The density of silver, which is given as 10.5 gram. It is given a density of silver is 10.5 gram per centimeter cube. That is given. Now, mass is 272.18 divided by density is 10.5 So this is gram and this is gram per centimeter cube. So the answer will be in centimeter cube. Calculate this part. You should be getting the answer as 25.92 centimeter cube. So this is the volume. And remember the volume, so that means area into thickness is equal to 25.92 centimeter cube. So area should be 25.92 divided by, which is centimeter cube, divided by thickness, which is given as 0.00254 centimeter. So the answer that we should get is 1.02 into 10 to the power 4. Unit should be, obviously area means centimeter square. So that is how this type of problem related to the thickness should be treated with.